So as an introduction to the Zoo project is an open source software. This is why we are at the FOSS4G. It is mainly written in C and C++ initially. It is an open source platform released under the MIT X11 license, which implements the following standards. So WPS standard version 1 and 2, because we are old. OGC API processes part 1 core standard, which is a newcomer. You know probably that OGC has moved from web services to OGC API, which is mainly based on Open API. Yeah. So we have the OGC API processes part 1 core standard, because it came out, it started in 2019. And then it was officially published. We have also the current draft specification of OGC API processes part 2, deploy, replace, and undeploy, which we are working actively on it. We are also involved in the OGC API processes part 3 workflow draft specification, even if I would have named chaining rather than workflow, because it is mainly about chaining currently. We are currently only implementing the remote processes conformance class. The idea initially of the Zoo project was basically to provide developers, which I am unfortunately, tools to make their life easier. So we try to have a standard canal for being able to use any kind of open source software which were already available within the OSGeo in a simple manner, in a standard manner. So here is a short, the long story about the Zoo project. So the idea came in 2008 in FOSS4G, Cape Town, South Africa. Our first talk was given in Australia in 2009, and from there at every new FOSS4G we tried to have a new release. So since 2012 we entered in a OSGeo incubation process, and we finally succeeded to and became an OSGeo project back in 2003. Back in 2003 also, the Zoo project were recognized as a reference implementation for both WPS2 and OGC API processes part 1 core. And finally, back in March of this year, 2014, we provided the Zoo project 2.0.0, and you can see that we have a new stuff for every new release. We will provide a DOI, document identifier, which is useful in open and reproducible science. So here is PSC, so you probably know a few of them. The newcomer is Fabrice Brito from Terradue, an Italian company, which is working actively with the European Space Agency on various projects where they are using the Zoo project. Here are the non-exhaustive list of developers. Okay. And here are the main components of the Zoo project. So we have the WPS server, the Zoo kernel, the Zoo services, Zoo API, and Zoo client. And for the very first time, I will present a slide that I made 3 years back, which is summarizing, I think, perfectly what the Zoo project is about. So on the left side, you have the Zoo client, which is a client which makes you able to communicate with WPS implementation. But nowadays we also have Swagger UI, which make you able to do the exact same. So you can communicate with Zoo kernel using OGC API processes part 1 core or WPS 1 and or 2. This Zoo kernel will then interact with Zoo services that can be implemented in any programming languages. Basically, this is why we have put GIDAL, which is implemented in C, C++, and this is GeoTool, which is implemented in Java. And Geos, which is a tool from within QGIS, which is offering you the buffer operation and so on. Then we think to ourselves that having multiple programming languages is a nice feature, but you still have to implement the code to make your service available. So we decided to move to another side, implementing support for existing processing engines such as Saga GIS and Orfeo Toolbox. And we are now able to automatically provide you access to this as OGC API processes part 1 core without writing one line of code. You just have to type one command and it will generate all the metadata required to execute those processes. What is interesting if you are an Orfeo Toolbox user is that you can also implement your own remote module within Orfeo Toolbox. And once you have deployed your Orfeo Toolbox with your new remote module, you rerun the same command again and you will have the metadata configuration file available. As you can see here, we are also able to execute remote processes on HPC server using Slurm scheduler and using the Zoo API, which is a small monkey here. You can chain existing processes and add logic using the JavaScript language. We will come back on this in a moment. And also, for every processes which is outputting something which is GIS related, you can ask by setting some use map server equal true in the metadata configuration file for your process. You can automate the publication through map server of OGC web process, web map service, web coverage service, web feature service, or lately, as I will show you later on, the OGC API features. So Zoo-kernel run on any platform, GNU Linux, Mac OS X, or Windows platform. Currently, nowadays, we are mainly focused on Kubernetes support, so we don't care that much anymore about the compatibility with Windows, I should admit. Since version 1.9 and upper, we have the support for OGC API processes part 1 core, part 2, and partially the part 3 too. Here are the list of the language we are supporting: C, C++, Fortran, Java, PHP, Perl, Ruby, Python, C#, JavaScript, and R. For JavaScript, we started before Node.js was out, so we decided to use SpiderMonkey, which was JavaScript engine based provided by Mozilla. So here is map server support. So with one request, we were willing in this application, which was made back in 2011, we were willing to provide a user interface for searching for the safest path for a bicycle. So when you send the request to use compute the shortest path, we were using PG routing. So you run this request once, and as a result, you will get a getMap request. This getMap can then be used to show the WMS on the map. With the same server, we can also request WFS because the map server is compliant with WMS and WFS. So we were able to show the details of the way of the path on the right, and as this result was stored on the server, rather than sending back these line strings that we have created to define the path, we simply reuse the request to the get feature as an input to the GEDAL elevation profile to have the profile along the path. So just to tell you, we also have the get status since the WPS1. So sorry for the, yeah, maybe I should do like this. Okay, this way we can see all the text. So the Zoo-kernel, as I was telling you, is supporting already Slurm, but as I will go back on this exact same topic, I prefer to switch to the next slide. So the first one was funded by another European project, but this one was for fidiashpc.eu, which is an European funded project, in which we developed a new kind of Zoo-kernel where you have the front-end Zoo-kernel, which is receiving the request. And for every asynchronous request you are willing to execute, rather than taking the request itself, it will send it to a RabbitMQ, and you have multiple servers that are handling the messages that are coming in this RabbitMQ queue. Last year, in testbed 19 HPGC activities, the Zoo project HPGC support was updated for enabling the deployment, the automating deployment of new application on the remote HPC. So using the OGC API processes part 2, you are basically sending your process description and the Docker image you are willing to deploy on the HPC. You send this to the Zoo-kernel. The Zoo-kernel will then connect through SSH to the HPC server to build your Singularity container and deploy it. And once you will want to execute it, you will use OGC API part 1 core, and then the execution will pass through Slurm. So after WPS, we moved to OGC API processes. What is nice with OGC API processes is that you have two conformance classes, one for HTML support and one for JSON, meaning that the communication is no more in XML, but in JSON nowadays. And you can build up a small user interface. So here is a very basic user interface based on Cheetah and the technology we made for MapMint that I will show you later on. So as I already told you that we are a reference implementation, we have actually to renew the reference implementation and rerun the test because our reference implementation is ending in next February. We have the map server support, which was implemented back in 2022 during the OGC, OSGeo, ASF code sprint. I want to especially thank Microsoft and Google. So Microsoft Azure for open source, which is a program where Microsoft is giving you money, some Azure credit, to make you able to use their Kubernetes cluster or to use their VM for free. And Google Summer of Code because they are providing new user to our community. The Zoo project is used in the EOEPCA, so Earth Observation Exploitation Platform Common Architecture, as the core of the processing engine, where using CWL you can actually deploy, you can run the CWL locally first on your computer if your computer is fast enough to handle the run, and then you can deploy the same CWL to run it on a Kubernetes cluster. So this is a Calrissian runner, and you can also use the exact same CWL to run it on HPC. So CWL is for a common workflow language. I'm not sure if you are aware about, but typically this is how you can consider a CWL. Basically, CWL is can contain code or will reference a Docker image, will define the input and the output provided by the CWL when it runs. Obviously, as it is Docker, you can have any kind of supported language, like Python, R, Java, Julia, C++. So this is how the Zoo Calrissian runner is currently working. When you are deploying the service using the OGC API processes part 2 draft specification, you will have the cookie cutter that will be transformed to your actual service, and this service will then, thanks to PyCalrissian, request Kubernetes to run your CWL on Kubernetes cluster. Obviously, if some task can be run in parallel, you have a scatter mechanisms that offer you the parallelism automatically. So Zoo project was also integrated last year during the Geodata Cube activity testbed 19 of OGC. Zoo project was linked with EO API because we have a new feature in Zoo project, which is the filter in and filter out, meaning that for every single request that the Zoo project will get, it will run the filter in before executing and treating your request. So in case you are requesting for stack, you just need to follow the route to the stack server and get back the answer right back. So we were able, by using this filter in and filter out, join EO API and Zoo project, meaning that for every single run, you can store, rather than storing your data as WMS, WFS, or WCS, you can store them directly in the stack catalog. Last year also in testbed 19, we were involved in the machine learning transfer activity, where the Zoo project was coupled with the Triton inference server and Neutron to use open neural network exchange format, which is able basically to use any model which was trained with TensorFlow or PyTorch or anything. You can convert it to an NX, and then you can run the inference with any other AI library. And also we continue the work this year, earlier this year, and currently also in the climate and disaster resilience pilot funded by the OGC, where we were able to deploy the inference using the CWL. Zoo project was also involved in the OGC activity named Open Science Persistence Demonstrator, where the idea is to include and give access to OGC API processes from within Galaxy and make you able to build up your workflow with a user interface. So here we can see that we have two services that are coming from CRIM from Montreal, and one services of it was Orfeo Toolbox BandMath computation, actually, very trivial one, from Geolabs. So about the ongoing development, we are expecting to release the OGC API processes part 2 deploy, replace, and deploy draft specification as soon as possible, probably early next year. We started working on OGC API processes part 4 job management, which try to align OGC API processes with OpenEO, which is a very famous way of executing tasks, but which look very similar to me to OGC API processes. We are also willing to integrate in this new draft specification the support for provenance from W3C, the prov-O format, using CWL prov, obviously, We want to also, we actually have already implemented the support for Argo workflow execution through CWL and OGC API processes part 2 draft specification. And we are working on using Toil to execute remote tasks on HPC using the exact same CWL that you can run as Argo or on your Kubernetes cluster. So about the Zoo service, the most important thing is that we are separating the metadata from the code which is executed when you are running the service. You can store it in our dedicated Zoo configuration file format, or you can also use the YAML format. But since version 1.7.0, you can also store this metadata information directly in the PostgreSQL database, which is far easier. So here is 3 lines of code to have your hello world example. So as Einstein would have said, keep it simple, stupid. So here are a few available services. Currently, when you are deploying the Zoo project, per default you have 704 services. Zoo API, so it is a way you can chain services using an adaptation of OpenLayer back in the version 2.12, if I recall properly, 2010. So here are a few examples of the MapMint1 version where we were using this Zoo API for georeferencing historical maps, for instance. Then we have the Zoo client, which is becoming a bit obsolete because now we have the OGC API processes. So we communicate with JSON. So if you are willing to write a JavaScript library, here it was more for being able to communicate with his XML language. After this, thanks to this Zoo client, still we have built up this new Zoo demonstration, which are available online. So the Saga demonstration or for Toolbox demonstration, this is the place where I live. Here are another example of MapMint 2.0 version, which integrate Bootstrap. You can see on the left some kind of timeline. It is an old school way of doing things, and the profile elevation profile below. Here is a renewed georeferencer, and here is a simple classification of raster. So we have moved to GitHub, and to preserve the fact, to preserve the work we made for every single commit on GitHub, we are running our private test suite to test that we are conform to the standard, but we are also building and running the new OGC test suite, ETS, the official one, and we run it on every single commit, making sure that if you are adding a new capability, you are not breaking stuff that was working earlier, and you are still conform with the OGC standard. So the project is available on GitHub, and you will have this kind of user interface down below. Once you have deployed it on your computer, it should take less than 10 seconds. Here is the Zoo project DRU official M chart that you can use to deploy it on your Kubernetes cluster. It's very easy, and actually we also have a scaffold YAML configuration file in the M chart, in the Zoo project, in the UEPK package, meaning that if you want to deploy this on your local Kubernetes cluster on Minikube or something like this, you just have to run scaffold space dev, press enter, wait for 2 minutes, and you will get all your pod coming up. So just to conclude, yes, on top of this Zoo project, we have built an amazing product which is named MapMint, which we are still reselling currently, actually, strangely. And it comes with its small friend that you can have on your pocket phone, which is MapMint for Me, MapMint for Measure and Evaluation, which is an Android application you can download on the web. And this is it for me. Obrigado. I told you I won't be long, so I was not long.